Assalamualaikum and a very good morning to you all. My name is Dr. Ahmad Maizi. I'm from Malaysia. This is among the video on the series for research gap. Okay, now I present to you research gap potential on the topic explosive pressing. Okay, this video is created to help you all because uh, naturally, students will say that doing master and doing PhD is difficult. Yes, it is difficult, but if you know the method, it's actually easy. Uh, because students do not know what to do. The experiment, the method, the simulation, what kind of simulation, what kind of experiment, what kind of material they want to use. Now I've taken my skill, I have knowledge and I have skill in doing research gap. Okay, now this is a kind of thing that may help you all in doing your research. Okay, all this article content is taken from ScienceDirect. Okay, you can download the ScienceDirect for free if you have access. If your university have access with ScienceDirect, you can download those abstracts for free. Okay. Okay. Regarding about the explosive processing topic, when I do the analysis on this explosive pressing using only abstracts content, they are potential for chapter 1. Chapter 1 will cover introduction, which is the research background of the topic, and then the problem statement, and then the research objective, and lastly is the expected result. Okay, those all those information you can get from abstract. Okay, you can get from abstract, and then I will cover on research methodology chapter. Okay, talking about explosive pressing. Okay, basically what is an explosive pressing? So you have heard about pressing. Okay, in your laboratory you have ultimate testing machine. That machine can give load up until 300 uh, 300 kilogram, which is around 3000 okay, 300 kilogram. It is the limitation of that machine. Okay, and then there are machine called heavy velocity compaction, high velocity compaction machine. It can produce the force uh, around 6000 ton. Okay, 6000 ton. Okay, so uh, what will, if you want more ton, you want 10,000 ton, 100,000 ton press. Okay, the only solution for you is using explosive pressing. Okay, so not many people can do that because you must have access to explosion. Your university must have access to explosion, and you must have permission from the police, permission from the military to do the testing. Okay, but however, for those research institutions that have this facility, proceed. Okay, because the research potential is so big. Okay, this is among the research background I've taken. People are studying about multi impacts. Okay, multi impacts. Okay, multi compaction, and then you need area die compaction and solid state sintering or Stunson on powder metallurgy process, then the sandwich panel, then the accumulated roll bonding, mechanical properties and fracture characteristic of stainless steel clad plates. And then they developed one software called multi-particle FEM modeling, effect modeling, and shock consolidation. Okay, so this explosive pressing uh, is applied for most of these problem. Okay, because it has this tremendous energy that can uh, that can give force for that your application. And then these are the problem statement that I've taken all from the abstracts from the journals. Uh, they are talking about continuity and uniformity of thickness variation of growth rate during treating for each layer, meaning that when you are doing multi-layer material, okay, and then when you blast them and then you use explosive pressing to compress that both multi material, many things will happen, such as cracks, such as not uniformity and thickness, damage to rear plate because of kinetic energy, poor wear resistance, okay, preserve intermediate layer and premature rupture, okay, compressed peak stress, rupturing damage. All this happen because you you find it difficult to control explosion. Okay, explosive force, many factors will affect if you are doing the research on explosive compared to machinery. You can control the force, you can control the environment, but regarding explosion, it needs a very experienced operator. That that is the case that you have to get help from expert in that field. Not many people are doing research on explosion, especially as if you type explosion explosive pressing. If you put the bracket on it, it only come up to not more than 30 result. Okay, on explosive pressing alone. Okay, because obviously uh, people and many research institutions throughout the world does not have the facility to do that research. Therefore, if you have that facility, you will be easy to you uh, to get your master and PhD because uh, nobody is doing it. Okay, and then uh, this is your research gap. You can prove to your supervisor that this is your research gap. Okay, talking about research objective, those abstracts they are talking about effect of particle morphology. They are going to study about particle morphology, bonding interface formation, microstructure evaluation, interface strength, multi impacts, okay, short time exposure, understanding the impact initiation mechanism, computer vision, machine learning techniques to predict material properties, air blast response for sandwich material, and failure mechanism, and many more. Actually, there are many more. Okay, but I only display a bit only. Mm, this is among the research objective. Okay, just remember explosion is very short time. Okay, compared to crash, although you see accident, uh, it is uh, it is short time, but explosive exposure is very short time. Okay, then we are talking about multi impact. They were talking about morphology, bonding, and many things related to explosion because it is uh, not many people can study it. Okay, then it becomes the research potential to you. And this is among the results, expected result written in those abstracts. Okay, among them I taken some of it. Okay, to give you some idea of it. Then deploying UHM WPE laminate as first layer core significantly lowered the center velocity of front face. Layered composite possess better uniform deformation ability to compare with materials of other layer. Larger composite layer thickness lead to crack conversion. Okay, drop of ductility. Environmental result indicate unusual interval rupturing damage phenomenon, and composite particle can induce both blast-induced diffraction and fragment, including perforation and clapper plate. This is among the result. If you can see all the documents, if you can get all the document that I have give you the link in the end of this video, you can see many result. Okay, this will give you some idea what you want to do and what you result that you want to get. Okay. For this chapter, research methodology, I have listed many equipment, theories, tools, material, equation, uh, many more. Okay, you can find it helpful to you because naturally student will miss many things. They know about only limited number of machines. When they read the journals, they may miss lot of things. Okay, using my knowledge in doing research methodology and doing research gap and using the knowledge that I have to find uh, this equipment result and everything I have listed to you. Okay, you may use most of them. The important thing is you must discuss with your supervisor if that machine equipment is available at your institution, you use it. If not available, just ignore it. Okay. Here I listed all the tests required. Among them are the tensile testing, compression shear test, mechanical testing, nano indentation test. Then the equipment called electron probe microanalyzer, corrosive steel test chamber, scanning electron microscope. Okay. And then the models and equation, this is for students who want to do modeling. Okay, and they are using analytical model, consistent modeling, finite element, multi-particle FEM. This is a popular one, multi-particle. You will find it many in those journal, multi-particle FEM modeling. And then equation, they are using Boltzmann transport equation. And then the simulation and behavior, some of you who are interested to do the simulation, you will use CFD, FEM simulation, numerical simulation, and also fragment simulation projectile. And then talking about behavior, okay, this is all the behavior uh, that you will encounter when you are using are doing this kind of research. This is you will not miss anything. Conduction, hailing, uh, dynamic compression behavior, and many more. And these are the properties and cracks related. Corrosion properties, dynamic impact damage property, mechanical properties, and then the back cracking, crack generation, propagation. You will not miss a lot of things. Okay, these are the fractures and mechanical related. You are doing fracture characterization, fracture failure, fracture mode, fracture observation, and then these are mechanical alloying, performance prediction, properties response testing. These are the experiment that you may use: ballistic experiment, impact initiation experiment, laboratory experiment, penetration, plane impact experiment, spore recovery. And then these are all among the methods that you want to use: vacuum hot pressing, powder metallurgy, precipitation method. This is the analysis. Among them are analysis of strengthening mechanism, analytical model, CT analysis, many more actually. Impact, explosive impact, high speed impact, fracture behavior, impact velocity. If you really see this list, you will not miss anything. Okay, you will not miss anything about this research. Okay, ballistic, and then air blast. Okay, the blasting, the air blast, ballistic strength, and we're talking about explosive. There are explosive charges, explosive electron emission, explosive welding, near field explosion, and then the talking about alloy, alumina powder, copper alloy, copper, and many things. Okay, particles and evolution. Talking about particles evolution, nanoparticle evolution, deformation, extract evolution, interface evolution, texture evolution, mechanism. You are doing experiment on damage mechanism, deformation mechanism, fracture mechanism, and then the boundary, the boundary condition, boundary morphology, particle boundary. And then the tensile, you may think only tensile strength. Actually, there are more than tensile strength. There are in situ tensile, longitudinal tensile strength, quasi tensile strength, tensile behavior, many more. things that you do not aware before this. And then the deformation, the bending deformation, back deformation, uniform deformation, elastic deformation, hetero deformation, strength, okay, ballistic strength, bonding strength, interfacial strength, and then the laminates, many kind of laminates and many kind of name of material, equipment and everything. Okay, you may remember only fatigue strength, but actually there are many more strength related you can analysis. Composite bonding, okay, composite projectile damage repair, composite bonding strength, cohesive bonding, explosive bonded interface, many more. This, and in the end, these are all the equipments that I mentioned on in all those abstracts. There are many more. I only present to you a little bit. Okay, you are using X-ray diffraction, scanning electron microscope, tensile testing, head specimen, EDS, AFM, shock wave, Vickers micro hardness, nano imitation, and many more actually. These are among the list of extracts. There are a total of 58 extracts. Okay, uh, 58 abstract I taken from those journals, and this is among the journal titles. What I suggest is, if you have the Sign Direct with you, if your university have Sign Direct, uh, you will have access to the all this abstract, and then you can download it for free. Okay, you can download abstract and for free. Journals your university have to pay. Abstract is given free. It's no problem. Okay, this is among the titles given when I do this analysis. And then for students who want to do this research, I have make the document to you, uh, around 50 pages or document. uh, the link to that document is given below in this video, in the comment section in this video, in the description section in this video. I wish you all best of luck in doing your masters and PhD. Don't worry, research is actually easy if you know the way, if you know uh, to do how to do research. Is actually easy. The first step is to find the relevant equipment, machinery and everything. Um, uh, this document have uh, at, at least 50% of your work you have you have shortcut lah. In short, uh, I will say that you have this document. If you can get this document from the link below, it will help you a lot. You will not miss anything. You will not miss any equipment, machinery, and you will get to know some objective. If you can study the all the abstract, you can know what you want to do. You can discuss with your supervisors, and you can prove that what do you want to do is your research gap. Okay, so thank you very much. I will see you in the next video, in the next topic. If you are interested to do to request me to do analysis on your related topic, you can uh, give in the comment section below. Thank you very much.